Thank you for coming, and I'm looking forward to sharing with you some of the materials that we've been learning about hoop house management, particularly for the long term, as we've said here. Let's do a quick show of hands and see. I'm going to ask you a few questions about how many of you have hoop houses and for how long. Okay, that'll help me judge a little bit about what to say. So, how many of you have no hoop houses yet? Okay, so that's at least half or more. One hoop house. Two hoop houses. Three. All right, 4. This is a hoop house serious crowd. 5. Okay, we got 8 at the student farm and still going. So we always tell everybody you got to watch. If you get 1 or 2 and there's any fertile ground around, they start replicating. Right? It's hard to keep them off there. How many years you've been growing in the tunnel? Okay, so those of you that have tunnels, just 1 year or less. Okay, 2 to 3 years, 4 to 5 years. Okay, more than 5 years. Anybody more than 10 years? Okay, so we started, the stuff I'm going to show you is in 2001 is the first high tunnels that I built, 1 on campus, or 2 on campus and 1 at home. And but even probably 96, so 4 or 5 years before that was the first year that I got a greenhouse, a hoop house-like structure on campus that had heat in it, and it was available at the horticulture farm. And we just built raised beds because the floor was already gravel. So in there, we've been growing since 94, so what does that make it? Almost 20, getting close to 20 years, and in the same soil, in the same boxes with no leaching, and all we've added is compost, and we're still getting pretty good yields out of that. So I'm going to use that somewhat as a framework of what we're going to share today. All right. So a lot of what you have is on the handouts. The one handout that's a 2-pager, lots of times we come and we give a handout and says, see this website. And I'm still concerned that people aren't taking advantage of all the information that's there for high tunnels. So the first on that page shows just a sampling of some of the material at the hoophouses.msu.edu. Adam and Laura have put quite a bit of information there, and lots about the economics of it also. So I really encourage you to take a look, and that some of the work that David Connor did about business plans is all up there and available. And I got a little frustrated finally last year of having so many talks that I've given and so many handouts and not having them available, that I started using the space available to me at the horticulture department website. And so that's the hort.msu.edu, John Biernbaum, and I've got 30 or 40 different talks in a bunch of different areas, including the high tunnel stuff, but the organic farming stuff, root cellar stuff, vegetable stuff, compost stuff. Worm composting is our newest thing, which you're going to hear a little bit about today. So please feel free to take advantage of all those resources that are there. All right, so let's go with that. All right. This whole idea of thinking about the hoop house. I think I'm going to, rather than wait and build up to the thunder at the end, I'm going to just tell you right here at the start. For years, we've been talking about the hoop house as a tool to extend the season. Okay, everybody's pretty cool with that. A little bit of concern as people get into having hoop houses for a longer period of time about what happens to the soil and do the salts accumulate. And do I have to take the cover off and let the rain leach? Or does it have to be a mobile hoop house? And do I have to move it? I think there's information to support some of that. But what it seems to be becoming clearer for me here in the last few years is that the hoop house, one of its best tools may be as a way of preventing the leaching of nutrients and accumulating nutrients in the soil to be able to produce what some people are beginning to call nutrient-dense food. Okay, so I mentioned this some in the last session. Part of who really helped it come together, I'm a book addict and read a lot. Steve Solomon, last year this book came out, The Intelligent Gardener, Growing Nutrient-Dense Food. And he's published a number of other really useful gardening books that brings in some different perspectives. But he shares about how when he was a younger person out on the West Coast and first reading Organic Gardening magazine when it first started. What was Organic Gardening magazine about when it first started? We got any folks that remember? It was about make compost piles and build your organic matter, but a lot about composting, what Rodale learned from Sir Albert Howard and from visits to Europe and things like that. And so Steve says how he went and he did all that, and he had a successful garden in Southern California, but then he finally got to buy his land up in the north, and he got land in Oregon, I believe it was, but on the west side of the mountains, of the Cascades. So what happens as the water and the wind comes off the Pacific Ocean, you get a lot of rain on that side, and the soils really got leached. And it was like, no matter how much organic matter and how much compost he made, things never seemed quite right. And as he moved away from there, he realized that he wasn't really all that healthy. His teeth weren't that healthy. And he just started learning more about health. And he started farming. I think he actually went to Southeast Asia and had some fertile ground and started getting healthier and started reading about soil testing and about nutrient balancing and realized that the whole idea of building organic matter that Rodale talked about works really well, particularly if you're in the middle of Pennsylvania, which is a state where some of the oldest ag lands in the United States. Lots of phosphorus fertilizers have been applied over centuries, and really the only thing lacking in those soils was organic matter to get the biology going, and then the nutrients become available. But what he was figuring out is that in some cases, like where he had his garden, on the west side of the Cascades, where the soils are leached and the minerals aren't there, no matter how much organic matter you add, if the minerals aren't there, you're not going to have healthy crops, you're not going to have healthy animals, and you're not going to have healthy people. Okay, and where does that sound like? Any place, where the soils are not very good? I remember the first time I was coming up here and visiting, I visited, I think it was Joyce who told me that. Joyce Wardell is a medicine person, a herbalist up in the Petoskey, and there was somebody at one of these conferences, maybe he said, you look at Michigan and all the different European cultures that settled, and said, yeah, the Irish came over here in the U.S. and they were wandering around trying to find a place where the soils were as bad as they were in Ireland, and they ended up here, around Traverse City, and all these sandy soils, and that idea that the soils really need to be worked with. And I grew up in South Jersey, on the sandy soils there, so I know a little bit about that. But we've got to look at building the minerals. And so as I put all this together, and I'm going to show you data from the soil analyses from the Student Organic Farm that we started taking in 2001, and we've taken them every year from the hoop houses about what's going on in there. And we see really nice high nutrient levels for potassium, calcium, magnesium, and we don't really worry so much about leaching, taking the cover off. And the question that I don't have is how does that relate to how nutrient dense the food is that's being grown out of there? I mean, I know our CSA members love it, but it takes quite a bit of dollars to be able to take that and analyze the tissue and see, as you get more in there, in the soil, are you getting more in the tissue? And what I was taught, I've had plant nutrition courses at my undergrad at North Carolina State, my master's at Penn State, and my PhD at Michigan State, and I learned all chemical forms of agriculture from, how to manage the soil from a chemistry standpoint, that if you have very low nutrients, as you go from low to some, you will see an increase in the nutrients in the plant. But as you go from some to more in the soil, you may or may not see more in the plant. So I'm not sure what the answer to this is, but I'm really excited about this. How do we look at building soil nutrient levels? And the one thing I am very clear is that a hoop house gives you the opportunity to build up the nutrient levels in your soil and not have to keep buying a lot of resources in because they don't get leached. That's what happens in most of our fields, and why we say from organic farming, don't over-apply nutrients, because if you do, they just get leached out over the winter or in the spring when things thaw out. So with that as background, let's see what we can put together and learn. We start thinking about soils, and hopefully you've had some of this stuff where we talked in the earlier session about knowing your sand, silt, and clay, which you can either send that out to a lab. How many of you have done the thing where you just put it in the jar and you shake it up and you let it settle? Cool, good. There's usually I don't get very many hands up. Very simple test. You can find the directions online, but it's just the sand essentially settles in the first minute. The silt will settle in the next hour, and the clay will settle over the next 1 to 2 or 3 days. And if you have 4 inches of soil that settled in this jar, and let's say that there's 2 inches of it is the sand, you just put a mark where after 1 minute, then you have 50% sand. Right? And if you have an inch of silt that settled after an hour, 1 divided by the 4 total inches, and you'd have 25% silt, and then you'd have 25% clay. Very simple, free test, gets you into the rough idea of what type of soil that you have. We're going to talk a little bit about pH. I spent 10 years of my life teaching greenhouse growers how to manage pH with acids and all other things because we need to do that in a peat-based media. Then I learned if you just put a little bit of compost in there, you don't have to do all that stuff. The compost and the other things help do that. So let's just look at this. I can teach a whole course around this slide, so we're just going to use it as an introduction as you start thinking about fertility. It's a combination of what's in solution, all right, and that's what goes into the plant. What's in reserve, right, that's the cation exchange capacity. So with clay we have that, but as we build organic matter, we have more of this ability to have reserve. All right, so we want, in an organic system, we typically want this to be big and this not so big. If you're in hydroponics, everything is in solution and you have no reserve. So it's like hydroponics is on one end of the spectrum and organic farming is maybe on the other end. So we're looking for that. What controls the movement from here to here? One big thing is pH, all right? The availability of the nutrients. And I ask students all the time in class, what does pH mean? Okay, and the ones that have had chemistry say the negative log of the hydrogen ion concentration. And I say, well, what does that tell you about why it affects plants growing? And it just gets really quiet. And then somebody will say, well, it's acid or basic. I say, okay, that's good. How does that tell you about how it impacts plants are growing? Right? So we've been talking about pH. Any of you had a good explanation of pH in here before? It's like, why does it matter for plants? Simply put, everything that goes into the plant root is dissolved in water. Okay? And the pH tells us something about the water. Most of the water exists as H2O. A very, very small amount of it exists as either H plus or OH minus. How small? In water at pH of 7, there's, instead of like 55, if there's 55 parts of this, there's 0.000001 parts of H plus. Pretty small number, but it has a lot of impact on what will or will not dissolve. So in an organic system, by having organic matter, we do need our pH to come near neutral, something in that 6 to 7.5. But in my tunnel at home, where I haven't done what we've done at the farm that I'm going to show you, my pHs are 8. Okay, and it's like everything I learned says is nothing should be growing in there, but it's growing pretty good, and it could be better if I brought it down somewhat. But it's mostly growing in composted horse manure, worm composted horse manure that's been added to the soil there. So we still have some more things to learn. The other piece of this puzzle is the balance of the ratio of the nutrients. And that's where soil testing comes in. That's what Steve Solomon was talking about, that many of us can be successful with gardening without ever running a soil test. Who would say they're in that category? You never ran a soil test, but you still got a good garden? Not very many hands went up. How many of you have done a soil test of your garden? All right, this is a good group. Like, these guys are like on top of it. So, and that is how you really get this other piece to really get the nutrients balanced and to make it all work. So, if we're going to start with that, I should just a quick reminder, how do you take the sample? Key thing in your tunnels, try to take it the same time of the year every year because it varies. The cycling is going on in there. And try to take it in the same way. All right? Try to have the same person take it. One of the biggest things that I feel like I contributed to the greenhouse industry, where we were doing work in pots, and I was trying to get people to do soil testing, and I'd go and consult, and it's like the numbers would be all over. We finally figured out that the salts at the very top of the pot were like 10 times as much as in the rest of the root. And so whether this top layer was included or not changed the values dramatically. So once we said, forget the top layer, just do the root zone, that really helped. And I think in the tunnel, I would tend to recommend, for the most part, just push aside that little top layer. You may see salt accumulating. You may actually want to take that and run a separate test on it. I'm going to show you where we've done that, and mostly it's potassium. It's not really bad things in our system. You know, if you had sodium or chloride, it could be a problem. But whatever you do, be consistent. Either take a core that includes the top layer every time or doesn't include the top layer, and be consistent how you take the sample. And then know what lab that you do. Most people are still doing a standard soil test just like we do in the field. And that's what I'm going to show you our results that we've been doing the last 10 years. The folks that are doing high tunnels in Minnesota and on the East Coast are beginning to recommend to growers to do a greenhouse type test, which is called a saturated media extract. You just take the soil and you just extract it with water, and it tells you what's really soluble. Whereas the normal test, the Bray or the Olson or the Malick, will tell you a little bit more. It's an acid extract, and it'll tell you about your reserve also. So you have to know which test to get. For the time being, we're going to start doing both. This year we did both. I didn't see anything that made me super excited to come here and tell you, do a saturated media extract, but we're going to try to figure that out. But be consistent with the lab that you're using.